All right, good evening, everybody. My name is Aiden Stockdale. I'm the Volunteer and Education Division Manager for Manatee County Parks and Natural Resources. So I often work out at Robinson Preserve. It's one of my favorite places to visit. And so when I was approached with the opportunity to work with all the folks who are doing the fisheries research out there and work on the restoration, we wanted to put together something to kind of share with the public what's going on out there, because oftentimes you'll see these signs and black boxes and people with big nets, and what are they doing? So we gathered together representatives from some of the different organizations that are doing some of the research, the science out at Robinson. And hopefully, if you all have any questions, we'll work to answer them tonight with the presentations. We are recording this, so we will put it online after the webinar is done. And if you have any questions throughout, just drop them in the chat. And I'll be sure, I'll prompt that to the different speakers, and we'll see what they have to say. All right. And with that, I'm going to present over to our first person. So our first speaker is going to be Sherry. So she's going to talk about kind of the background of Robinson Preserve, some of the restoration work, and what's going on behind the scenes with the new section we affectionately refer to as the expansion.
I'm excited to be part of this event and to have this opportunity to share information about what, in my opinion, I share Aiden's thoughts on Robinson Preserve. In my opinion, it's one of Manatee County's most amazing natural recreation areas. I recently started my role with Manatee County, and I've been serving as Ecological and Marine Resources Division Manager for the past 6 months. Although the highly collaborative Robinson Preserve expansion started well before my time with Manatee County, I have been fortunate to inherit some of the responsibilities for keeping Robinson Preserve a place for residents and visitors to continue to love and visit for decades to come. So we're going to talk a little bit about the science behind Robinson Preserve. Many on this call are likely familiar with the preserve already. For those who are not, the preserve is located in Manatee County, in the western side of Manatee County, south of the Manatee River and east of Creeko Bayou. The Robinson Preserve expansion, which will be the focus of today's discussion, is outlined in teal and was the site of extensive coastal habitat restoration that converted fallow agricultural uplands into an ecologically diverse habitat mosaic, complete with passive recreation amenities. At the time of purchase, the 150-acre expansion area contained fallow agricultural lands with invasive exotic vegetation and dredged soil mounds. Today, the reshaped landscape provides an ecologically diverse habitat mosaic containing coastal uplands, tidal marsh, submerged aquatic habitat, and juvenile for fish nursery habitat, which we'll be discussing today. One of the driving forces behind the Robinson Preserve design was to provide a haven for juvenile sports fish. My predecessor, Damon Moore, who I think might be joining our call tonight, and my current manager, Charlie Hunziger, collaborated closely with the fisheries biologists to create a fisheries-focused design that met the primary needs of juvenile sports fish, including life cycle, food, shelter, protection, and thermal refuge. I will touch briefly on each of these features before passing the discussion to the fisheries biologists that are joining us today from the Florida Fish and Wildlife Research Institute. The research scientists, these research scientists are conducting research that drives adaptive management decisions we make in the future to ensure the preserve remains suitable habitat for juvenile fish. Sorry, I lost my train of thought. So first, the life cycle. The project incorporated features for different life cycle stages of fish. The site was designed to incorporate spawning areas and tidal estuaries for larger fish, tidal flowways to disperse eggs, and areas with variable salinity such as backwaters to protect newly hatched fish larvae. Food is also important. The design provided variable habitat structure to attract food, including vegetated shorelines, woody debris, and oyster habitat, which is shown here. Each feature was added as a way to attract a variety of smaller feeder fish and invertebrates that in turn could provide food source for juvenile sports fish. Thermal refuge is also critical for developing juvenile fish in order to provide gradients of water temperature. The design incorporated deep holes and shallow flats, areas with sun versus shade, variable substrates such as mud, sand, and oyster reefs, and different vegetation types, including emergent grasses and mangrove trees. So you'll notice that these two fish nurseries and the oyster reefs here, we'll be talking a little bit about those areas. The fish nursery areas on the previous slides were designed to provide a haven to protect juvenile fish from larger fish predators. To create the nursery habitats, pinch points were created to mimic natural inland coastal ponds. Several techniques were used, including culverts, oyster sills, hanging vertical oyster gardens, and vegetation. The goal was to create a natural mangrove barrier, such as the Manatee River example shown in the bottom right photo, which I just took yesterday, and I think is really amazing. We are currently planning to enhance these natural vegetation barriers throughout the preserve. And finally, shelter. Juvenile fish benefit from protected places to hide. They prefer areas with little to no water flow that is protected from currents, wind, and waves. Emergent vegetation also provides needed shelter. Mangrove and marsh grasses have been planted to provide that vegetative structure. Our next phase, which will be discussed following the fisheries science presentations today, will include innovative features such as floating islands to provide shade for juvenile fish and nesting substrate for shorebirds.
All right, so I'm going to pass this over to one of our scientists with Florida Fish and Wildlife Conservation, David Blewett. So he's going to be talking about the fish abundance and nursery habitat in Robinson Preserve. So with that, if you want to take over, I'll pass it over to you.
All right. Really glad to be here tonight and to get to share some of the work that we've been doing in Robinson. It's a pretty exciting project and a lot of fun to work on and to do this presentation. We're gonna just look at our monitoring program with these newly created sportfish nursery habitats. And like Aiden said, I'm with Fish and Wildlife Conservation Commission. So yeah, I work with Fish and Wildlife Conservation Commission. I'm with the Fisheries Independent Monitoring Program. And we monitor fish populations throughout the state and most of the large estuaries in Florida. I'm out of the Charlotte Harbor Field Lab, and Megan, who's going to be talking to you soon, she's out of the Tampa Bay Field Lab. And we have staff from both of those labs coming together and working on this Robinson Preserve project. And kind of coming back to our title, what is a fish nursery? So it's simply just habitat that provides young, or what we call juvenile fish, the proper amount of food and protection from predators. So it's really about food and shelter, which Sherry touched on quite a bit. And sportfish species in Florida, they have a wide variety of nursery grounds. So, like certain habitats are better suited for certain species. Gag and red grouper, for instance, they prefer high salinity estuarine seagrass beds. Spotted sea trout will use seagrass beds all throughout the estuary. And sheep's head, they'll use flats and shallow embayments that can have seagrass, oysters, or mangrove. So basically, those nurseries are in the open estuary. Those are places where you can take the family boat, and they're not hard to get to typically. But when we start to look at species like snook and tarpon, these juvenile fish push much further up into the estuarine landscape. So in natural areas, places like where I work in Charlotte Harbor, here's some photos of some coastal ponds off the Cape Hayes Peninsula. And tarpon and snook push way far up into the estuary using tidal creeks, upper portions of tidal creeks, and then actually swimming over black mangrove forests when the tides are high and getting into these coastal ponds. Unfortunately, this coastal salt marsh habitat was targeted in the 50s and 60s for saltwater developments and saltwater access and housing developments. And so you can see in the red boxes here, these areas are coastal marshes, and there's quite a few ponds. All these areas were converted into Punta Gorda Isles. And that's happened all over the state. So loss or degradation of this nursery habitat means there's less places for juvenile fish to grow up. And so now we're attempting to add sport fish nursery habitat into wetland restoration and creation projects. And some of those recent restoration projects that have added sport fish nursery habitats are rock ponds, which is in the lower Tampa Bay, and Lemon Creek Wildflower Preserve and Coral Creek, which are on the Cape Ace Peninsula of Charlotte Harbor, and of course, Robinson Preserve. Our overall monitoring goals in Robinson Preserve is to track and compare juvenile sport fish abundance and fish communities among the different created water bodies. Also, we want to assess juvenile sport fish age, growth, and body condition. In addition, we want to assess tidal connectivity and water conditions, which relate to certain habitat design features among the different water bodies. But tonight, I'm just going to focus on this number one objective, and that was to track and compare juvenile sport fish abundance among the different created water bodies. So in our monitoring, we're in the Robinson Preserve, we're using two seine types, 9-meter seine, and a meter is about 3 foot long. So, we're looking at like a 27-foot seine and a 40-meter seine, which is much larger and has a little bit larger mesh. So the 9-meter seine's geared to capture more of the juvenile sport fish and small forage fish, whereas the 40-meter seine will catch some of the larger juveniles and adult fish. So we use a random sampling design, and for all of our sample sites are selected randomly throughout and evenly throughout the different water bodies. We're collecting information on all fishes and selected invertebrates. We're getting abundance information and size information. And we're also recording the habitat at each place we sample. So shoreline vegetation, seagrass coverage, depth, water conditions such as temperature, salinity, and dissolved oxygen. We're sampling 7 of the water bodies at Robinson, 5 which were created recently in 2020, and 1 created in the first phase. That would be pond number 7, and then 1 natural water body, number 6. And of course, within the preserve, we've got varying connections to the estuaries with these different water bodies. And in water bodies number 1, 6, and 7 are what we're calling open water bodies. They're more open to the open estuary, whereas water bodies 2 and 3 are the entrances have the oyster sills, the mounds where it's a little more difficult for larger fish to get in at certain tides. And then pond number 4, I keep saying pond, but water body number 4 is entrance is a culvert and a shallow ditch. And so we're going to kind of call those kind of coin some frames of like terms of open, protected, and highly protected. And a couple footnotes on this slide. Water body number 6, you might not be able to see that it has a connection to the open estuary, but there is a large channel, large and wide channel that does connect it up there at the top. You can kind of see, it is covered with mangroves, but it's a deep access. And water body number 5 is a closed freshwater system, has no connection with the estuary. And so I'm not going to talk about that during this talk. So here's another look at some of the slides Sherry showed. This is what a sill looks like. It's just a bunch of shell piled up high, and with some plantings of mangroves to try to inhibit larger fish from coming back into those protected areas. And then over on the right side, we've got this shallow ditch that leads to pond 4. And here are the culverts that go underneath some of the pathways. So basically, we're hoping that black mangrove will take this area over. And this is a picture here of a black mangrove forest in the Cape Hayes Peninsula, which snook and tarpon will swim 100 feet to 1,000 feet through these black mangrove forests in order to get to protected coastal ponds. So here's some preliminary results after our first phase of sampling. And this is just going to be our 9-meter seine data from October 2021 to December 2021. And during that time, we pulled 102 seine hauls. We collected over 40 different species of fish and selected invertebrates, and 5 different juvenile sport fish species. So here's a look at our small forage fish that we collected. This is not all of them. We collected, of course, 40 species, but this is some of the top players, some of the ones that were most abundant. And so we have the Mahara, bay anchovy, silverside clown goby. Those are found more in the open water, but I kind of have them angled just to show you that there's kind of like a, it's not real straightforward. These fish don't always behave, you can't put them in boxes, but generally speaking, this is kind of where they fall out. And so you have the gold spotted killifish, the rainwater killifish, kind of like in those protected to highly protected areas. And then what we call our marsh, our really marsh species would be the mosquito fish, the sheep's head minnow, and the sailfin molly. And these were our 3 most abundant juvenile sport fish that we collected: snook, redfish, and sheep's head. We also collected a few spotted sea trout and permit. And we also opportunistically captured some tarpon in one of the water bodies. It wasn't in our random sampling, but we were able to see and capture some of those fish to get some measurements. So I'm going to share with you now some of the catch rates during that 3-month time period. And basically, we're looking, those numbers that you see where it says pond number 2, 4.2 snook per 100 meters squared. 100 meters squared is basically like a 30 by 30 area, 30 feet by 30 feet area, if you were to kind of imagine that. So within that area, in that water body, we're looking at pond number 2 having 4.2 snook per 100 meters squared of area. And so when you see the different sized icons of fish there, that's for relative to abundance. So if you see a larger snook, that's more abundant. So you can see that protected water bodies, there's quite a few juvenile snook using those nursery habitats, which is great. That's what they were designed for. And some use in the open water bodies too, of 1 and 7. No snook were collected in the open water body of 6, and none were collected in the highly protected water body number 4. For redfish, again, the protected water bodies have high catch rates, and some decent catch rates in the open water bodies too for red drum, and also 0.8 redfish per 100 meters squared in the highly protected water body number 4. No redfish collected in water body 6. Here we have sheepshead. And sheepshead are higher abundances in the open water bodies and some in the protected water body number 3. None in number 4, number 2, or number 6. And then here we come to the tarpon. In October of 2021, we saw hundreds of small juvenile tarpon rolling in water body 4. They came close to the shoreline. We were able to use our 9-meter net to collect some and get some measurements. And those fish range from 6 to 10 inches. So it's good to see that the tarpon are using this highly protected area, which is what we would expect because that's what we see in nature. And so in summary, of course, these results are very preliminary. We documented juvenile sport fish using newly created protected water bodies with sill entrances, and those were our expected nursery areas for snook. Juveniles also using open water bodies too, but to a lesser extent. Very few juvenile sport fish collected in the highly protected water body number 4, but tarpon appear to be using that habitat, which is encouraging. And so far, no juvenile sport fish collected in open water body 6, which is very interesting. And 2 more years of sampling to go, so we're excited about that. And we're also excited to present some of the information that we're gathering from the 40-meter seine. And we'll be able to determine abundance of the larger predatory fish within these different water bodies and see if these water bodies, if these nursery grounds are indeed keeping out some of these large predatory fish. And I thank you all. And if I think we're going to field a few questions.
Yeah, so if anybody has any questions, go ahead and drop them in the chat. One that was sent over, one of the forage fish you mentioned, the sailfin mollies, are they a native species?
Yes, sailfin molly is a native species.
And what kind of waters do you tend to find them in?
We find them in really shallow water. Salinity can vary. They can handle pure fresh. We catch them in pure fresh, and we catch them in hypersaline. So from 0 parts per thousand to 45 parts per thousand, which is way higher than ocean seawater. So it's what we call hypersaline. So they're really hardy fish made for the marsh, because the marsh conditions, the waters in the marsh can change quickly. You can have hypersaline conditions in April and May, and then get the June rains, and then all of a sudden it's very fresh. And so those fish thrive in those shallow marshy coastal areas.
A couple more questions came in. So why were there no fish observed in pond number 6?
Okay, yeah, that's a good note. So we're catching some fish in there, but yeah, no juvenile sport fish were collected in that water body. Our guess is that it has a lot of access to the open estuary, so we feel like there's not much protection there for juvenile sport fish, and the depth of the shorelines is kind of steep for say really small juvenile snook. So there's a couple things. That area does have some beautiful black mangroves. So if at some point, if that ditch were ever to be able to be filled, it probably would become a tarpon nursery at some point. But right now it's just too open. We catch fish more like sardines, which you typically don't find in backwater areas.
All right, and one more question. How do the parent fish get into the protected waters, or at least how did the juveniles get there?
Okay, so a lot of these fish that we're talking about, like snook, tarpon, and redfish. Okay, so snook spawn in the passes, in the inlets and passes, and red drum and tarpon spawn about anywhere from 20 to 100 miles offshore. And so that larvae travels in, uses currents, favorable currents, inshore currents, to come into the estuary, and then they push way back So at a larval stage, they're actually pushing back into these mangroves, and then they'll transform into young juveniles, and they'll continue to push back into these wetlands. And what happens is we have high tides in the summer. We have extremely high tides that help push the water, way back into the estuary, and these fish ride those currents and get back into these tight places. And then they'll grow up into these areas. And then when conditions are right again, when the waters come up, the next summer or whatever, they can ride those high tides out.
All right, we have a few more questions, but we'll circle back to those towards the end. I want to pass it off to Megan. So,
all right, great.
All right, thank you very much. All right, so next we'll have Dr. Megan Trent with Florida Fish and Wildlife, the Florida Fish and Wildlife Research Institute, also with FWC. She is going to be talking about the acoustic monitoring of the sport fish throughout the preserve.
So I'm going to kind of continue on and piggyback off of Dave's talk. So Dave was talking about the Fisheries Independent Monitoring Group and how we are monitoring the fish populations within the different habitats within Robinson Preserve. And I'm going to chat a little bit about an additional project that we're doing that's related to that one. And it's actually going to try to answer the question of whether those juveniles that are growing up in Robinson Preserve are actually leaving the preserve and then potentially contributing to the adult population in the greater Tampa Bay area. And this question about whether it's contributing adults as a nursery habitat can be an information gap for some of our restoration projects, but it's a really good realistic metric for evaluating the success of those restoration projects. So there's a lot of different ways that we can try to answer this question. And the method that we're using is acoustic tagging. So the idea here is that we are going to tag juvenile sport fish within the preserve itself. And then we're going to track their movements from the preserve to the greater Tampa Bay area. So usually Tampa Bay and Sarasota Bay. And then also their movements within Robinson Preserve. So we can get a little bit more information about how they might be moving from one pond to another and when those movements are occurring. So acoustic tagging works through a series of tags or transmitters that are implanted into fish. So on your screen here, you'll see some fish that have some little black bars sort of in their stomachs. Those are representing the tags, and those tags emit short pulses of sound, and that sound communicates a unique identifier or a tag number for that particular fish. And then you'll notice also in that photo there are some receivers, or you can think of them as listening stations. There's 3 of them on the floor of the ocean there, and these receivers will listen for the fish to swim by. We call those pings. And the receivers actually store the date, the time, and that unique identifier for that particular fish when they swim past that receiver. So on the slides, you'll see the word receiver, but you can just think of them as these listening stations because they're actively listening for those tags. So when the fish swims by, the receiver will pick it up and store that information, and then we can download the data later on. So when we're acoustically tracking fish, we want to make sure that we are listening to them in areas that are important to us and of interest to our question. So remember, our question here is whether the fish are actually leaving the preserve and moving to those adult habitats. But we're also interested in what they're doing within the preserve. So we are going to place some receivers within the preserve. So the map on the right-hand side of your screen there, all the yellow circles are the receiver locations. So there's 7 receivers that are placed in different water bodies within the preserve. And then we have 6 that are placed near the preserve exits or presumed exits. And those are the ones that are going to track fish into those subadult or those adult habitats outside of the preserve. Now, one thing to note is that these tags within the fish can continue to ping until no battery power remains. So our tags are designed to last about 2 to 3 years. So if you think about that, in 2 to 3 years, a fish can actually move a very large distance. And hopefully, if they are leaving the preserve and going to those adult habitats, they will move a greater distance. So then the question becomes, can we track them beyond just our hydrophone array or our receiver array that's set up there in the preserve? And to do that, we can actually rely on acoustic telemetry networks. So acoustics is used by many different researchers for a lot of different questions, a lot of different species. And if we use similar equipment, the tags can be heard by other researchers' receivers, and then we can also hear some of their tags as well. So the map here on the left, every single colored dot or square or diamond actually is some type of receiver or listening station. The orange star in the middle lets you know where Robinson Preserve is. So our receivers basically fall right around that orange star. And then if our fish move elsewhere, we can collaborate with these other researchers who have their listening stations out there as well to get information about our fish. And then when we hear from their fish, we can give them information as well to let them know that we've heard them on our array. So the first thing we need to do is set up our receiver or listening station array at Robinson Preserve. So the map on the right is the same map as before. All the yellow circles, remember, are the receiver locations. And what we've decided to do is we've placed receivers out there, but we've also paired them with water loggers. So we've got 13 receivers and 13 water loggers. The pictures on the left-hand side of your screen are pictures of the actual receiver and the water logger itself. So the receiver is sort of laid on its side there. It's that gray and black cylinder. And the water loggers are stored within that PVC pipe that has little holes in it in order to let water flow through it. And then the two pictures on the top left let you know what they look like out in the field. So that's an example of one of our receivers that's actually outside of the preserve. So after we've got the array set up, then it's time to start tagging our large juvenile sport fish. So in order to capture fish to tag them, we actually use the same 40-meter seine that Dave was talking about in his talk. And so we use that to try to target these larger juveniles. And the idea here is that we want to tag fish that are just about ready to leave the preserve. So we want these large juveniles before we would expect that they would be ready to leave and join that adult population. And if you remember from Dave's slide, he said there were about 5 different sportfish species that they were seeing in their monitoring efforts. So far, we have been able to tag 3 different species. Here we've got Atlantic tarpon on the left, red drum on the right, and then in the middle is a picture of the tag actually being implanted into the abdomen of the fish. To date, we have tagged 5 juvenile Atlantic tarpon, 13 common snook, and 4 red drum. And our goal is actually to tag 40 fish per year, about 20 in the spring and 20 in the fall, and we'll do this for 2 years. So just to give you some quick project updates and quick hits, we started the project actually just January 1st of 2022, so this is a very new project. In April, we deployed all 13 receivers and got those set up. Later in April, we were then able to start pulling some nets, and we tagged our first fish for acoustics. So far, just in the directed or targeted seine net sampling, we've identified 44 different species of fish. We have tagged 22 individuals for acoustics. And then August 23rd and 24th was our first download of data. And the exciting news here is that we have heard from all 22 tagged fish in some capacity. So we're hearing fish, they're moving around, so that part is working. And then today, September 15th, we have released our project website. So I have the link here and I can post it in the chat later as well. So you can go to this website and you can kind of keep tabs on this project over time. So the idea is that the website actually gives you some background information about the preserve and tagging, and then the project itself and our methodologies. And then eventually we'll also start adding in some data summaries and some quick hits for information. But like I said, we did download data in August, at the end of August. There's a lot of data to sort through, so I'm just going to give you some very preliminary, very general results here. just to orient you to what you're looking at here on this slide, across the bottom is going to be the date. So it ranges from May to August right now because we tagged about mid-April and we downloaded at the end of August. On the left side, you see 5 different colored fish. So these represent an individual fish that has been tagged. And when I add the actual data to this graphic, what you'll see is sort of a horizontal line of dots, and those dots are going to be color coded for whether that fish is inside the preserve, so it's pinging off of any of those receivers in the preserve, or if it's outside the preserve, so then it's pinging, off a receiver that's located outside the preserve. So we can look at this first top fish here as an example. So it was tagged about mid-May, and then we hear from it within the preserve through June. Then we don't hear from it from a little while. It's probably moving around within the preserve at this point. And then in July, we hear from it outside the preserve, and we hear from it again right before August. So right now, this fish looks like it has left the preserve. Obviously, we don't know if it is coming back or anything yet because we don't have data yet after August. That will be after our next download set. So not all fish are behaving the same though. So we've got a couple other ones up here just to give you an example. So all of them start with green dots, depending because they're all tagged within the preserve itself. And then they can spend different amounts of time within the preserve before leaving. And then even if they do leave, they might leave for a while, or they could leave for a very short period of time and then come back right back in essentially the next day. So it's just interesting to see that, we've got these different fish behaving a little bit differently, and then they're spending different amounts of time in different areas. But the fish are actually leaving the preserve and some of them are returning. So they're not stuck within the preserve, which is good. And then eventually we'll see, as we get data from other researchers and those other arrays, along with that network of receivers, if the fish are being heard in other locations as well. So if you remember, the main question is really determining the contribution of juvenile fishes to the adult populations, or those fish that are leaving the preserve and going to Tampa Bay, Sarasota Bay, the greater population, in order to spawn and grow up, contribute more to the population of the fish. So right now we can't put a number on it. It's still a work in progress. Obviously, we're only a few months in. We've got about 2 to 3 more years of data collection. Our tagged fish are still juveniles, so we also need to allow them to grow up and leave the preserve for good, hopefully. And the idea here is that we can actually calculate a percentage of fish that left the preserve and a percentage of fish that stayed within the preserve. So we know from our tagging data how many are tagged, and then how many of those tags actually leave the preserve. Now we can actually take that one step further because of the monitoring work that Dave had presented just prior to this talk. So remember from Dave's talk, he was able to calculate or estimate a number of fish per meter squared for those small juveniles. So we can use that information because it's per area, and we can then combine it with the area of juvenile habitat that's available within the preserve in those water bodies, and then look at the percentage of fish that actually have left the preserve from the tagging information in order to get an estimate of how many fish are leaving the preserve and contributing to the adult populations. And we can do this on a species specific basis because we've got those species specific, fish per meter squared estimates. So we've got a few years to go, but we will, keep pushing out updates, and we will continue looking at the data to help get some more insight on what these fish are doing around Robinson Preserve. So with that, I'd just like to say thank you, and I will take any questions.
I have a couple of general questions that I'm actually going to save to the end because we'll do a little bit of a roundtable. But one of the questions was actually about grant funding and what kind of grants go into the research being done here.
So I can speak for this one. I'll let Dave chime in for the monitoring work. So this project, the acoustics project, is actually funded by a Tampa Bay Environmental Restoration Fund grant from the Tampa Bay Estuary Program. And I'll let Dave chime in for the funding sources for the monitoring work.
Okay, yeah. NOAA Restore Science Program and National Fish and Wildlife Foundation.
And, you know, grant funding makes a lot of what we do possible, from the restoration to the research, you know, improving Robinson Preserving, keeping it pristine, and making sure we're doing the right things in the right direction. We rely pretty heavily on grant funding to make this happen. All right. And with that, Nathan Brennan did pop on.
Dr. Nathan. I'm working with Dr. Ryan Slosher and some of my colleagues at Mote to help with this Robinson Preserve project. We just started. Okay, I can't quite see all that. There it is. Okay, so we have these monitoring objectives here. I didn't think it was going to do that. Sorry. So what we're doing in our project is to seine and catch some of the and tag and release some of the larger and smaller fish within the preserve. And then we've also installed, we're working with 4 solar powered antenna systems that we placed at passageways and specific connection to monitor fish movement. And so we're also looking at just habitat use, survival, migration, and movement patterns using these continuously monitoring systems that are powered by solar panels. And our seine data will also provide some information on the growth rates that we see, which it has been pretty phenomenal. Some of the species, I was pretty surprised to see our target species are economic value. So common snooks, tarpon, red drum, spotted sea trout, and mangrove snapper and striped mullet, black drum and sheep's head. Basically anything of interest that would be helpful to understanding how the restoration is working in terms of the habitat and fish recruitment and habitat use. So here's the picture of a PIT tag system. It's PIT stands for the Passive Integrated Transponder. It's usually either 23 millimeters or 12 millimeters long. You can scan them with a handheld detector. The receivers use the power. In this situation, the tag does not have a battery in it, unlike the acoustic tags that Megan was talking about. The tag read range is between, with the antennas that we're using in Robinson, it's about closer to 24 inches read range on the antenna loop itself. Tags generally have really great retention, depending on the location of where they're implanted in the fish. And each one has a unique tag ID. And these tags are actually the same type of tags used with cities and counties with pets, such as dogs and cats. So it's usually in fisheries, we are tapping into the technology elsewhere to apply it to our work because of it's not really developed well. So here's a schematic of an antenna system. This is a side view here. We've got a battery system, and we power these batteries with solar power antennas or solar powered panels that recharge the batteries every day. And then we have a tuner box for these antennas. We have to get the inductance correct to get the right read, range, and tag code detected. And also we have a data logger that collects the recapture information and stores it, and we can download it at various times over the life of the system. So we're putting these at aggregation sites, and these things are running 24/7. So the solar power systems are doing a good job of recharging the batteries, and they seem to be working quite well. We've made some adjustments to get these to work with high salinity systems such as Robinson Preserve. And then this is all going to help us understand what's happening with the fish in the preserve. Here's the a slide of the existing locations of the 4 antenna systems that we have in Robinson. So the northern part of the slide, the upper part, that is monitoring the lagoon here. It's also known as water body 4. And Dave mentioned it, but the yellow little bars actually represent the antenna loops themselves underwater. And so basically this lagoon system is isolated from the rest of the preserve. There is a small trickle ditch there that allows water to come in with tide each day. So we use that system to actually monitor anything that goes in or out if it has a tag with the antennas. Then the north bridge over to the left, upper left, there's a bridge there, and we've got an antenna on either side of the bridge, and then also further into the water body. And then moving down to the main water body itself, water body 1, there's a main bridge on the lower left side of the slide there. That's got 3 antennas on it currently. We were able to actually get one to span all the way across that broad channel heading outward from the preserve, which is about 80 feet. So that was we were happy to see it work there. And then we're also monitoring the nursery antenna system. It's on the lower part of the screen there. But that actually has a third opening, which is that other bridge just to the right of the last yellow antenna indicator. But we haven't been able to install that. We're hoping to get another system involved that can help us monitor that part of the system to actually, that way we'll be able to actually document who's going in and out with a pretty good confidence. We're getting most things involved. Here is a picture of one of our antenna systems. The stand has the battery box on it, which includes the solar power converter box as well as the batteries. And then to the side of that, there's a data logger system. That's the tag, that's the reader box we call. And so these have these cables heading out towards these antenna loops at different places. And this one, you can see the orange wire shows the actual loop, and we've got all 3 of those culverts monitored here. And on the other side of the road, there's another one of these that moves the other side. And then we have one in the upper right picture there. You can see the antenna underwater coverage spanning right across that lagoon. So with our seine work, we use a 71 meter long by 3 meter deep seine. It's a bag seine, 3/8 inch nylon mesh. And we're looking for larger sport fish mostly, but we'll tag anything that can actually accommodate a tag, which goes down to juveniles. This sampling area is about 600 square meters. And we've got some catchability data on them for snook, but that's not really, but we're going to be doing probably, we're actually working with 3 sampling events per year for 3 years of this project at the moment. And here are where we're doing our seine efforts. Because we're not actually documenting abundance, like Dave was talking about, we don't need to worry about the exact same effort every time, but we basically have 12 to 14 seine sites that we do in a given event. And we're trying to hit most of the water bodies within the preserve to get a representative catch. And we've also included a one more system that we call the dogleg system, and it's the green pond to the right of the slide there. And that's the system that seems to have tarpon in it. We've caught them several times now. Here's some of the results so far of the seine work. We've got the species here listed of who was caught in May, and then in comparison with the March sampling effort. I don't have the data yet for our most recent one that we did in August, but so far we've got 225 or 183 tagged in May, and back in March, which was still kind of the winter season, we had 407 individuals tagged and released into the preserve. So the pit tag systems have been running. There's been a few spots that have intermittent performance, but we've got that resolved. So as of August 1, we had over 162,000 pit tag detections from these antennas. This represents 365 uniquely tagged individuals, and that's over 92 detection days. So this database can expand quickly. Here's an example of some of the data we're getting with snook. So you can see the detection data is on the x-axis. The body size, I ranked them according to size. So this little box, upper box in the upper left shows you, like, for example, oops, code 1 was only 120 millimeter snook, which would be at the bottom of the graph. And then some of these upper codes up around 80, we have up to 800 millimeters long. And you can see, based on the dots on the graph, those are recapture sightings from the various antennas in the preserve. But basically, see the middle between March and May, there's kind of a gap there. And what we think is going on here is that of the snook that we tagged, most of those took off and left the preserve, and then they arrived back in again. There are some interesting things here where some of these really big snook are staying around, which surprises me because it's not the same as a tidal creek. So it is nursery habitat and overwinter habitat, but different. It's a new system, so we're finding interesting results that, in my opinion, I haven't seen this sort of a result before. The real small fish, you can see they're basically in the preserve the whole time. And once they get a little bit bigger, though, they start moving around. Here's some more data from the antennas. This is sheep's head, and this is broken down based on, we tags in here that we had to split the graphs up, but basically the you can see like all the tags that we released in August, you can see it way over in the lower graph there on to the right side of the graph. Those are newly implanted fish. And then you can still see some of these older ones that were tagged back in March. But basically the sheep's head that we tagged in the preserve seems to be basically staying in the preserve. And they tend to, they will eventually leave as they get bigger, but given the sizes and the possible ages that we have, we think that these are still nursery bound individuals. Here's some striped mullet results. Once again, you can see the pulses of fish when we tagged in August or in May. You can see a bunch of new tags in May and then in August as well. But so this data, this is preliminary, and it's going to take some work to get through this, but you can see the different codes and symbols that represent immigration at the various corridors and things. And when they look like a star, that means they're going both ways, both directions. So we have some really good data here, but we're just trying to sift through it all and without crashing the computers. So here's one of the tarpon and red drum. So the top graph is tarpon. We only actually tagged one tarpon outside of the dogleg system, which was tagged in the main water body. And you can see it's fairly present throughout the timeline here. It's in and out, but basically stay within this area. It's still what we consider a juvenile tarpon. They'll grow up to 9 feet long eventually. And then we have these red drum here. These are staying in the system as well so far. And I think it's similar to the sheep's head situation where they're just still young and they haven't quite left yet. But the fish condition seems to be through the roof. It's really great. The size and the fatness of the fish is phenomenal in Robinson. This doesn't show that. This is just about movement here. But now I have a few size structures that I wanted to show you. So here, this is Robinson Preserve Red Drum, March 2022. You can see this on the upper graph to the left side, the neon green, that's the young of year red drum in the system. And then these fish that are a little bit larger, around 300, 350, up to 600, those are older year classes. Whoops. Sorry. But by May, a lot of the drum left the system. So we're not sure what's going on there. There's not a lot of data. This is from the seine recaptures. So we have to couple this with the pit tag antenna system recaptures. And then here in August, there's not a lot of red drum around, but there are a few. And interestingly, the lagoon seems to have several instances of red drum being found in there. Here's a snook. The first upper graph shows the young of the year, once again at the right side of the graph, or the left side. And they're in the lagoon, the dogleg system, and all other parts of the preserve. But you can see a huge cohort, a big chunk of those numbers are these larger fish, and these are winter. This is during winter, so they're actually overwintering in the preserve. It's an adult overwinter habitat. And then by May, the numbers go way down again. But there are a splattering of different sizes in there in May, and the last one's actually supposed to be August. So here's tarpon. So all these orange ones are from the dogleg pond in the preserve there. So you can see these young year in the top graph, and then they seem to be growing a little bit, but the numbers really drop down by May, and then by August we don't see a lot of those young years anywhere, and we haven't actually picked them up on our antennas either. So I'm suspecting that they are possibly being eaten in the system. That dogleg system has a one-way flap valve on it, only allowing flood tide water to come in, but not allowing well, actually it's the other way around. It only allows rainwater that's filled into the dogleg pond to leave the system with the one-way flap valve, but the high tide marine water will not come into it because it's a one-way flap. And so it might be that they're leaving, but we would think since we tagged a decent amount, we should have probably picked them up with our antennas out there, and we haven't seen them yet. So this is kind of a mystery still. Here's the striped mullet. The main thing here is that you see the recruitment on the lower graph, the newest baby mullet showing up in August, or some of those are in the dogleg system, but a lot of them in March are found in the preserve here, the larger fish there. But once again, this is preliminary, so we've got to figure out exactly what's going on here. or make our best guess about it. Here's some sheep's head size structures. I'm not going to go into all of these, but the sheep's head, these sizes aren't like adults yet. When they get to more like 400 and 450, those are more adult sheep's head. So these are still considered adolescent or juvenile sheep's head within the preserve. And then we also got some black drum, which were really cool. They're the ones that make the loud grunting noises. If you ever catch one, they'll make noises. It's a drum, the drum species in the family. They have that ability to do that. Okay, and so that's the end of my presentation. I've got some extra slides here, but I'm not going to go into those.
All right, so I'd like to pass it over. Sherry.
All right, so hi again, Sherry Swanson. So I'm just going to wrap up with a few slides to show you what's on the horizon. Basically, Manatee County uses an adaptive management approach to make decisions at Robinson Preserve, and this is based on the information that we obtained from our land managers, from habitat monitoring tied to permits, through vegetation planting, successful or otherwise, and importantly, communications with the fisheries biologists. And this information helps us figure out future design enhancements that could be needed. So this brings us to phase 3 Robinson Preserve. We are currently in the early planning stages of a phase 3 expansion in the expansion, which will be funded with restore money. Some of the design enhancements we may be looking to make in 2023 and beyond include measures to better protect juvenile fish. So you can see here, here's pond 4, and there's the man-made swale we've been discussing in the north of the preserve. And we're also possibly looking to do some enhancements to optimize fish passage in pond 3 as well. We're looking to possibly add some more mangrove plantings at pinch points, some floating vegetated shade islands that can be used to create shade and shelter for juvenile fish, but also nesting for shorebirds. And supplemental plantings throughout the preserve is going to be a big component of the funding. And then that's actually 1/3 of the funding. The other 2/3 of the funding, we are looking to expand the fish monitoring efforts by the fishery biologists that have been presenting today. So we're excited that we're going to be able to do that. So just quickly, here's 4. I had this in here, we were talking about the man-made ditch. So one of the ideas we're discussing now is adding some black mangroves to that area to make it a little more difficult for larger fish to get up, but also possibly replacing some of the smaller culverts with a more natural, wider culvert to make it a little more natural and for the fish to move between, and then more plants. As I mentioned, the pinch points with the red mangroves, floating vegetative islands to provide shelter for the fish. So those are just a few things we're discussing now. We're in the early stages, but one of the big components will be to continue to do the fish monitoring at the preserve. And that is all I have.
All right. I want to wrap up. Well, we have a few questions in the chat. A couple. I'll go ahead and tackle. One of which was asking about like the birds and which fish they eat. A lot of the research we're doing right now is specifically on the sport fish. So we're not really doing a lot of research on the birds, but we do have an ongoing kind of like citizen science effort to look at bird populations. So if anybody's out there and a birder, we always recommend, submit your lists to eBird. It's a great website, and we're able to kind of check that ongoing throughout time to monitor bird populations and see, like, if you report interactions, you notice ospreys are grabbing redfish or anything like that, you can also report that through there. So it's really cool tool. Also, iNaturalist as well. Those are ones that we monitor on our end. There's also a question about impacts of algae such as like red tide and other algal blooms. The big part of those is, often we do get the oxygen in the water. So especially with the like algae mats and stuff, the algae will bloom and you'll have a decrease in oxygen as it decomposes and all that oxygen is being used up in decomposition. And that, low oxygen is bad for environments and it can cause fish kills. One of the things you may see at Robinson are these turbidity berries. Actually, I think the ones up there just came down today as the weather's been dropping a little bit and getting a little bit colder to help prevent some of those floating algae mats from coming in tidally from Tampa Bay. But it is a thing we monitor. I mean, algae blooms have always happened, but we're noticing, a greater frequency with greater nutrients levels in the bay. So it's definitely something we keep an eye on. Now I had a question for about the acoustic tags. That was so I can share. So this was a picture that was shared with me, but I can actually pass it over because I think we have a live one that you can show in your hand. Is that true?
Yes. So actually, I just ran down the hall when I saw that in the chat. So yeah, the perks of staying at the office late at night. Yeah, so this is what our tags look like for our fish. So the acoustic tags are going to range in size depending on how big of a fish you're tagging and also how long you want that battery to last. So, once again, we're tagging those larger juveniles, which are, still pretty small fish. So this is the tag that goes in them, but this tag will last about 2 to 3 years, pinging off of those different receivers. So the larger ones are about the size of basically a chapstick tube. It's probably the best way to describe their size. So, but this is the one that we're using.
So this is a question for anybody who might have an answer, because I'm not sure about this one. How do storm surges and hurricanes and tropical storms impact fish in the estuaries? Does anybody have any insight into that?
Hurricanes have a wide variety of different effects in the estuary, and it's really hard to pinpoint exactly what happens during a hurricane, but there have been several studies. In Charlotte Harbor, we had a low dissolved oxygen event after Hurricane Charlie that affected fish populations in the harbor for about a month. Dissolved oxygens went really low, but then returned and recovered. There's some there are a few studies out there, but the effects seem to vary from storm to storm. So it's really tough to to say how a hurricane's going to affect fish populations. But one thing that is interesting about snook and tarpon is that their spawning season is basically during the late spring and summer, and then actually into the early fall, and which coincides with our hurricane season. And so what we notice in Charlotte Harbor and the Cape Hayes Peninsula with these natural salt marsh ponds is that when we have storm events, we get tides anywhere from 3 to 4 foot from some of these storm events, whether they be a tropical storm or a hurricane. And those storms help push larvae and juvenile fish up into these ponds. So we get higher recruitment of fish in the ponds when we have storms. And then we get higher emigration rates. That means fish that are already a year or two old that have been living in the ponds and are ready to get out, they're able to get out. So storms are, vitally important for the movement of juvenile fish in natural systems.
And while I got you around, I have a question that probably is more up your alley. So the preserve seems to have large populations of offshore species such as grouper. So what's the estuary or the juvenile habitat for species like the grouper?
Okay, yeah. So for grouper, the adults live offshore, spawn offshore, and larvae comes into the estuary. For species like gag and red grouper, their nursery ground is the seagrass beds that are closer to the pass, so or the barrier islands or your sounds. Those, and typically there's seagrass beds that are anywhere from 2 feet deep to 6 feet deep, and that's where those fish will grow up before leaving, before going offshore.
Awesome. Well, thank you all on behalf of Manatee County and Robinson Preserve. Thank you all very much for coming out tonight. Thank you to our wonderful, wonderful co-hosts tonight, scientists from FWC, from Mote, Manatee County staff. Thank you all for your support and enjoying Robinson Preserve and being curious, because that's kind of what makes us go, is people being curious about the world around them. So thank you all very much and have a great evening.